Part 2. All right, I think we can finish. So it says find the determinant of A, which is a 2 by 2. See, this is the easy part. We already did this during Kramer's rule. So we multiply this way, -6 minus always -12, and they're those darn double negatives. Those are the only things that can really get you. So -6 plus 12 is 6. So there's the determinant. The real reason for finding that is because now they're asking us to find the inverse function, which is 1 over its determinant. That's what this says. So 1 over 6 times, now we follow the formula. A and D switch diagonally, 1, -6. C and B stay the same, in the same position, but they become their opposites. So -4 becomes 4, 3 becomes -3. Now a lot of you guys are going to be tempted to now do the same thing. Find the determinant. That's not what they're asking. They want the inverse matrix. And so to figure that out, we just need to now distribute this through everything. So this hits this, hits this, hits this, hits this. So 1/6 times 1 is 1/6. 1/6 times -3, -1/2. 1/6 times 4, 2/3. 1/6 times -6, -1. Now what's significant about this, just in case it's asked of you down the road, if I actually multiplied this by this, I would end up getting the matrix 1, 0, 0, 1, because it's just like 6 times 1/6 equals 1. Anything times its inverse, reciprocal in this instance, is 1. This matrix times this matrix would give me this, which if I calculated this, would be 1 minus 0, there, which is 1. I throw that in for free. But I don't think you're going to be required to know that, but you never know. Okay, number 8. So it gives you a 2 by 2 and a 2 by 2, but this is more algebraic now, so they're going to mess with you a little bit. So 2a, we're going to multiply everything by 2, so 12, 4, 6, 8, minus 3 times b. So I'm keeping the minus there, so 9, 3b, 3a, and then -12. And again, I'm ignoring that because I put it right there. So now it's a subtraction problem. 12 minus 9 is 3. 4 minus 3b, I put that in the top. 6 minus 3a goes in that little spot. Then 8 minus -12 is 20. There's my answer. Just following the rules with more of an algebra feel. A plus b, well, because this is a 2 by 2 and that's a 2 by 2, we can add them. So 6 plus 3 is 9. 2 plus b is 2 plus b. 3 plus a is 3 plus a, or a plus 3. 4 and -4 is 0. And we're done. Okay, graphing these trigonometric functions, not going away. So remember, amplitude equals the absolute value of a. We'll get to that in a minute, but let's start by looking at the parent function, y equals cosine of x. So that looks like this. And then we do the adjustments. So there's my amplitude. That'd be the absolute value of a half, which is just a half, which means it doesn't go up 1, because remember this actually had a 1 there, so it only goes up halfway. It only goes down halfway. Again, I use dotted lines until I'm done. Then I start introducing more colors so I don't get confused. So, if we recall, one step at a time, we've got this situation right here, which we learned. We can just think of that as right pi. So I'm going to take that dotted one right there and start introducing some colors. That's going to come to the right pi. So that negative pi comes to here. That peak right there goes to here. I guess this 0 could move over too. Or also, starting to lose myself. Okay, yep. And that 0 could have moved right here. And then this low spot could have gone right here. So we literally just moved it over pi. Tried to anyways, looks pretty good. But now what we're going to do is take a look at, if we were to multiply this through here, it'd be 2x. And remember, that's identifying this as b. Remember, a period is 2 pi all over the absolute value of b. In this case, it'd be 2, so that would be pi. So maybe I should have done this over here, but I'm going to do it now. Notice we have, looks like I screwed this up in the period. Let me check this out a minute. Yeah, so some of you probably noticed when I did this, this just came jetting out too far. It was supposed to be, I'm just going to go over it with a pink, it's supposed to come right here so that my period is 2 pi. So that was a good safety check that I just went a little wonky right there, so that should not be part of my one cycle. So my new period is pi. So I know from here to here, my wall right now is right here and right here. And I'm going to bring those in. I'm going to bring that in here, and I'm going to bring that in here. So I'm going to get out a new color for my new walls, and I'm going to squeeze that pink one in this distance. So this comes in here, and it's going to come in here. This moves here, and there it is. That's pi. That's my new period. Am I done? No. The final thing I got to do is move that whole thing down 2. So this gets a little confusing, but this is only supposed to be up a half. So I go down a half, and then down 1.5. So that peak is supposed to be right there. And then these zeros go down to -2. That 0, whoopsie, I'm at that 0. We go down to -2. That's how easy it is, you guys. So I'm going to finish off this side. If that's down a half, then it needs to be down 2.5, which would be right out there. I'm just trying to duplicate this. And once I kind of get that feeling, then that 0 goes down to here, and that spot goes down to there. And that's not perfect, but it's pretty good. So there it is, number 9. Done. Not without its challenges. All right, we got 2 more problems. And it says solve the matrix equation, and this gets a little confusing, but if you just remember your rule, it's kind of like telling you, hey, we got matrix A and matrix B, and if we concentrate on this, this is like a PEMDAS sort of a problem where no parentheses, no exponents, but we do have a multiplication problem right here. So this row times this would be, in the upper left-hand corner, that'd be 5x plus 6y. And there's no more columns, so I'm going to go down to here. So this times this times this would be 2x minus 2y plus 4, 6 equals 2. Whoops, I didn't mean that. 2, the matrix. Now, before your brain wanders, this is one term, and this is one term. So it's just like if we had something like this with numbers. This is just a number, this is just a number. Your brain has to just prevent itself from looking at this like a 2 by 2. It's not. It's a 2 by 1. So 2 rows, 1 column. Okay. So what does this say? It says this plus 4 equals 2. So I'd add this spot, I'm going to make them all orange, plus this equals this. So it's 5x plus 6y plus 4 equals 2. Now I'm going to subtract 4 from both sides because I can see where this is headed. I just don't know if it's going to turn out nice or not. And then this plus this has to equal this. So 2x minus 2y plus 6 has to equal 2. So I would go 2x minus 2y, subtract 6 equals negative 4. Now I'm going to divide all that by 2 simply because I can. So I'd get x minus 1, y equals negative 2. Now I made this problem up, so I'm not sure if it's going to work out super nice or not. So we got this system of equations. So I'm going to go ahead and multiply this one by 6, just trying to eliminate my y's. So I'm going to get 6x minus 6y equals negative 12. I'm going to add this one to this one, because I can see my y's are going to cancel. And so I get 11x equals negative 14. I had a feeling this was going to happen, because I made it up. So x equals negative 14 elevenths, but that shouldn't be a big deal. Now I'm going to plug that back in here to find y. So negative 14 elevenths minus y equals negative, now see that negative 2? I'm going to make that negative 22 over 11ths just to get common denominators. So I'm going to add 14 elevenths, add 14 elevenths, so I get negative y equals negative 8 elevenths. So that would be positive y equals 8 elevenths. So there's my x, there's my y. Now, number 11, I wasn't sure whether to throw this on there or not, but I did. So we got this nasty, nasty, nasty problem here. It says, using Kramer's rule, solve the following system of equations, should be an S there, for C. So, the first thing we're going to have to do is we're going to look at this. We're going to turn that, it's supposed to be in here. Turn that into a 4x4. And yeah, you can use your calculator, but when I do that, when I look at this on your test, I'm looking for work. So here it comes. 2, 3, 2, 5, 1, negative 2, negative 1, 1, negative 1, 2, 1, negative 1, 1, negative 3, negative 3, and 2. I might change the instructions. I might just say, instead of saying solve for C, I'm going to say find D, which is the determinant. And then, you guys should then know, from your formulas, that to find A, it would be dA over D, and then to find B, it'd be dB over D, and so on. But we're just finding D, and I think that makes more sense as far as time goes. So this right here is here. I'm just looking at the coefficients of all of these, A, B, C, D. I'm ignoring the constants. Now if I was to find C, I would find this, then find DC by replacing all the coefficients, these, with my constants, and turn it into another nightmare situation. But let's just deal with this nightmare situation. So when we take stuff out, Kramer's rule, now we got 4 things to take out. It always goes plus, minus, plus, and because we have another thing to take out, it's minus. So take the 2 out, and make a line, negative 2, 2, negative 3, negative 1, 1, negative 3, 1, negative 1, 2. Now, we're going to take the minus out and pull the second term out. Make a line, 3, 2, negative 3, and 2, 1, negative 3, and then 5, negative 1, 2. Now we're going to pull out the next term. Negative 1, make a line, 3, negative 2, negative 3, 2, negative 1, negative 3, and I'm pulling this one out, 5, 1, 2. Running out of space. Am I still on the camera? Yes. All right. I got to pull that 1 out. I have to write a little smaller maybe. Make a line. 3, -2, 2. 2, -1, 1. 5, 1, -1. And the more I think about it, the more constricted we are with time, I might say something like get to here and then use your calculator to find all of these. Seems a little ridiculous right now to expect this, so I'm probably going to make it a bonus. The more you do by hand, the more points you're going to get. And if you just plug this in your calculator, you'll get something, but it will be minimal. But you can kind of see where this is getting, minimal, yeah. So I'm just going to show you what you would do if you have time for this one, which you'd have to do for this one, and this one. This one, then I'd have 2, then I'd have to take this out, so as you can see, I'd have -2, line, 1, -3, -1, 2, minus, because that's the way Kramer's goes, 2, line, -1, -3, 1, 2, plus, take that one out, -3, line, -1, 1, 1, -1, and now we finish this. So this, I'm not worried about this, but this is -2 times 2 minus 3, which is -1, minus 2, -2 minus a -3 is -2 plus 3, which is 1. And then I got a -3 times 1 minus 1, which is 0. So this is just from the innards here. So I got 2 minus 2, look at this, minus 0. This is 0 times 2, 0. So this whole thing right here equals 0, and you'd have to do that again and again and again. So that's a crazy expectation for you guys, but I decided to throw it at you. All right, that finishes your test review. Good luck, you guys. If you like the video, like and subscribe. Gotta go viral someday.